I heard M. Scott Veach, lying son of an astronaut, tell Spurs chemo.
Oh, what I can do is provide you evidence that accumulates in favor of that. But in science, we don't really prove things, right? Science doesn't prove things. It accumulates evidence in favor of a hypothesis.
Just go ahead and detail the difference between supposition and presupposition, because on two accounts, like when I was watching an old video of Neil deGrasse Tyson, he brings up Galileo and how after that point they had science. And then I heard Michio Kaku say that they don't use the scientific method, but after Galileo they had these telescopes and now they can begin to look into the universe and do all of this science. Well, can you, because you said, I heard you explain what a presupposition is. Can you explain the difference between supposition and presupposition?
Sure. So supposition is something that in scientific vernacular is yet to be validated. So your supposition in a hypothesis is your independent variable. That which you presume, suppose, not presuppose, suppose, causes the effect. So that's a supposition of the cause of the effect you're studying, your independent variable. A presupposition, which is what we detailed with Arwin yesterday, trying to weasel it in and describe it as a presupposition that's come after a measurement, therefore no longer a presupposition. Presupposition is based on the conclusion that's going to follow. So it's presuppositional if it's the basis of your conclusion. So the difference, let's use an example we've already had. So a hypothesis. If it's a supposition, it is the hypothesis prior to experimentation. It's just the detail of the null and the independent and the dependent variable, right? That's your supposition. So when you read that supposition, it says, if A, then B. Now that is yet to be validated. Supposition that A causes B. Right? Now if you ignore the fact that you haven't put it through the experiment stage, that would be to say to validate your supposition, and then just take that hypothesis to be an explanation, then it's a presupposition. Because you read the exact same thing, if A then B, and you go, if A then B. That's my explanation now. Rather than a supposition yet to be validated, it just becomes your explanation. This is the cause of that. That's a presupposition.
Science doesn't prove things. It accumulates evidence in favor of a hypothesis.
Make sense? If not, I'll explain it again in a different way.
So could I say, when they say the Doppler effect is showing that objects in space are moving further apart, is that a presupposition?
That's a presupposition.
Amazing. Thank you.
They've got an effect, which you could call redshift, right? That's an effect. Would you agree?
Agreed.
How do you validate the cause of an effect?
You have to manipulate it, right?
You have to manipulate your supposed cause of it. So this is where the genius of science lies, because what normally happens is you go, what causes redshift? Yeah? Now, I'm not supposing that you should draw correlations with things that you can generate that aren't the effect you're actually observing, because that's what they'll actually do. I'll just get that out of the way straight away. But you've got to suppose you know the cause of redshift and then actually vary it to see if it causes it. Now, if you just take that which you're describing, let's say you're saying Doppler effect is the cause. It's like it's an effect, but let's just do it anyway because it's what you said. Doppler effect is the cause of redshift. It makes no sense, but let's just throw it out there just for ease of the explanation. Well, then you vary Doppler effect, scratching my head to make this make sense, and see if it causes redshift. And if it does, then you validated your cause. But if you just say, in my hypothesis, I've got if Doppler effect, then redshift, and then I just don't validate it and say Doppler effect causes redshift, you've just presupposed it.
Thank you. Seeing is that I'm being more keen to this happening, I would assume, and I could be wrong, but I would assume that a lot of people aren't clear on this because, again, if you ask someone, okay, what's a valid hypothesis for astrophysics, they'll bring up the Doppler effect. And then they'll begin to presuppose instead of actually showing you an experiment that validates the supposition. But it may look like it's science because they're like, look, here's this effect. This is what's happening. We see it happening. But that's begging the question too then, right?
Unless they've...
Or am I mixing all this up?
So you just have to go through the method. It's knowing the method inside out, back to front. So you're saying, okay, they're suggesting that scientific validity is to be had in just saying Doppler effect. You're like, oh, no. If it's an effect that we observe in nature, then we can study it with science. So Doppler effect is your phenomena, potentially. If we observe naturally occurring Doppler effect, then great. You can science the cause of it by presupposing no, but by supposition of cause validated by experiment. So, step 1, observe natural phenomena. What's our phenomena? Doppler effect. Okay, let's have a look at it. Let's see it doing it. Because it's an occurrence, that's what a phenomenon is. Something happening. So let's see it happen first in nature. Fine, it happens in nature. I wonder what causes it. Then you move on to step 2. Formulation of hypotheses. So you formulate your if this, that's your presupposition. No. Your presumed, yet to be validated, cause of the effect. So if A, then this natural phenomena will happen. But it's also got a null. If A, this natural phenomena will not happen. So then you validate it by way of experiment. You vary A and see if it causes the effect you're studying. And if it does, you validated it. You do that over and over and over again to make absolutely certain that it is actually the thing that you've supposed caused it. When you do the test again. That's the systematic experimentation. Repeatability in the experiment, not in the observation. Not repeatedly seeing Doppler effect. Repeatedly varying something to cause it. And if you vary it and it doesn't cause it, you know what happens? You, get this, validate, that is, prove your null. If A not B, so you vary it and not B. So if A, you vary A and not B, that is your prediction in the null. So when science is decried as not proving things, as I heard M. Scott Veach, lying son of an astronaut, tell Spurs Chemo, they're liars.
Oh, what I can do is provide you evidence that accumulates in favor of that. But in science, we don't really prove things.
We don't really prove things.
Science doesn't prove things. It accumulates evidence in favor of a hypothesis.
Can you?
I'm not saying that it doesn't prove anything. I never said it doesn't prove anything.
You just said it doesn't prove anything 20 seconds
No,
ago.
I didn't say that.
The method has a null. And at the end of the systematic experimentation stage, one or other will be proven. That's all it does when you do an experiment. Either the null or the alternative is proven. That's all science does. Vary A, doesn't cause B. I have proven my null. Science proves things.
I think you're right, though. You said a couple of weeks ago that you were going to talk to QE about going through the scientific method again. I think it's necessary because they'll turn around and tell you that, no, that's keeping science in a box and science has advanced past the scientific method.
Yeah, that's what somebody who's going to make up a story about a light in the sky having been collided with by Thea and the debris through gravitational accretion forming the moon, they're going to tell you that that individual that made up that story is going to tell you that science is advanced beyond empiricism. That would be proving things to, well, we don't really prove things with our stories. They kind of evolve. You're like, so it's advanced to just so stories that change with time from empirical validation. Wow, what an advancement. No, it hasn't. Science still proves your null or alternative upon systematic experimentation. That hasn't changed. It's still empirical. But that's not really good enough if you can't provide that in your just so story. So you'll say, as a quack pseudoscientist, that science has evolved into your just so story method, when it hasn't.
Well, that's what y'all were getting on the edge of earlier, was how necessary is it to be accurate with your description of the phenomenon before you can even enter into science.
That's correct. And that's why I sort of half disclaimed what I did rather than just going with it when I talked about Doppler effect being the cause of something, which is ludicrous. I had to drop in those disclaimers knowing full well that your current vibe is to say, if you're going to describe a phenomena, you've got to have a very, very accurate description. And we've all got to go through the Socratic method in agreement of what we're actually studying. Because if you just have a wishy-washy vague idea about what you're studying, the thing chances are doesn't even bloody exist. You can't study the cause of it.